Hi guys, welcome to the part 3 tutorial of Apache Kafka. So let's start. So producers, uh, producers as we know like write data to topics. As we already know, topic is made up of partitions. Producers automatically know to which broker and partition to write. In case of broker failures, producer will automatically recover. So producer send the data to a topic, as you can see in the picture. Topic A have three partitions 0, 1 and 2. So which partition the producer will use it is as based on the round robin fashion. So first it will use partition 0, partition 1 and partition 2. So it will automatically like the broker will automatically balance the load. If one partition is getting many messages, then it will automatically move the messages to other partitions. In case like there is some issue with the broker, then it will other brokers will come into action and things will continue to work as usual. Producers can choose to receive acknowledgement of data rights. For example, while sending the messages, we can set acknowledgement. If acknowledgement is 0, like producer won't wait for acknowledgement. Acknowledgement set is to 1, then producer will wait for leader acknowledgement, and acknowledgement all means leader plus replicas. So these are three acknowledgements that we use while sending messages to Apache Kafka. Producer message keys. Producer can choose to send a key with the message. Key can be of anything like a string, number, etc. If key is null, data is sent round robin. Like when producer is sending data, it will automatically go to a broker first, second, and then third. And if we have like send the key while producing the message, then it will automatically go to that particular partition. Key is basically a sent if you need message ordering for a specific field. So if you want a message to be ordered, you send key with the producers, right? Now let's talk about consumers. Consumers, as we know, like read data from a topic identified by name. Like each topic has a name, and consumer reads data from this topic. Consumer know which broker to read from. In case of broker failures, consumers know how to recover. For example, consumer is reading from a broker and somehow that broker stops working. So it will automatically um, the next replica will continue to cater the messages. Data is read in order within each partition. So topics have partitions and consumers read topics. So they read data in ordered fashion. For example, if they are reading from topic A and partition 0, then they'll be like getting the message number 11, 10, then 9 and all subsequent messages. So consumers groups is a concept like consumers, they are always in a group. They always read data in consumer groups. Each consumer within a group reads from exclusive partition. What does it mean? Basically, for example, if there are three consumers in a consumer group, and if consumer one have read the message, then consumer two will not read the same message again and again. So these are the exclusive partitions. And if you have more consumers than partitions, then some consumers will be inactive. So for example, you have a topic which that have three partitions, and you have five partition, then like first three partition will start reading from the first three consumers will start reading from the partition, but remaining two will be inactive. Delivery semantics for consumers, like consumers also have delivery semantics. Consumer choose when to commit offset. Basically there are three types of delivery semantics: at most once, at least once, and exactly once. In at most once, offsets are committed as soon as message is received. If the processing goes wrong, the message will be lost. So you receive the message, offset is committed. Offset committed means the message from the partition has been removed from the topic, or say partition has been removed. In case consumer is not able to process that message, it cannot again read the same message. So that message will be lost at least once. So offsets are committed after the message is processed. If the processing goes wrong, the message will be read again. This can result in duplicate processing of messages. So in that case, what we do is like we have to make our processing idempotent, which means processing same message twice will not impact our system. The third semantic is exactly once. So exactly once can be achieved for Kafka to Kafka workflows using Kafka Stream APIs. We'll be talking about Kafka Stream APIs in uh, further lectures, but it's a separate API which is defined for this purpose only, for exactly once semantic. So guys, that's all we had in part 3 of Apache Kafka.